Hi, my name is Charles Wang, and today I'll be explaining to you how to solve the greatest common factor for two or more numbers. So, when you want to solve the greatest common factor, you need to know what factors are first. Factors are numbers you multiply to get another number. For example, 3 and 2 are factors of 6 because 3 multiplied by 2 is 6. To factorize a number means to break it up into numbers that can be multiplied together to get the original number. Let's break up some factors for 50. 50 and 1, 50 times 1 is 50. 25 and 2, 25 times 2 is 50. And 5 and 10. These are all factors of 50 because when they're multiplied by another number in this set, they can be equal to 50. Let's move on. The greatest common factor. The greatest common factor is the largest factor that appears in two or more numbers. Let's do an example together. Let's solve the greatest common factor for 18 and 9. So 18, what are some factors of 18? 18 and 1, 18 times 1 is 18. Yup. 9 and 2, 9 times 2 is 18. What are some factors of 9? 9 and 1, what else? And 3. So let's see which ones are in common of these two sets of factors. 9 and 9 are common, and 1 and 1. But it's the greatest common factor. So this is asking you the greatest one. So 9 is greater than 1. Therefore the answer would be 9. Let's move on. Now let's talk about factor trees. Factor trees are very useful when it comes to solving the greatest common factor. First, write down the first number. Okay, so let's do an 45 and 60. First, write down the first number. Yep. Then branch off with any pair of factors of your number. You can really branch off with any pair. You can do 15 and 3. You can do 5 and 9. You can do any pair. So I'm going to do 5 and 9 for this example. So now each of your branches should have a factor of your number. Now, if one of your factors is a prime number, stop and underline it. And do not keep going. I'll show you that later. Remember, a prime number is a number that only has two factors, one in itself. So I told you, don't keep going after. Because when you keep going, it's going to go like this, this, and yeah, go on forever. And it will also not work for this method too. Let me switch to pen. Okay, so you underline it. 9 is not a prime factor. So now keep branching off until all of your numbers are prime factors. 3, these 3 can be do this. And then now let's do 60, and now let's do 60. Do the same step with all of your numbers. Yeah, do 60. So let's do 60. You can really do any pair of factors. You can do 20 and 3. I'm just going to do 5 and 12. So 5 is a prime factor. Don't keep going. 12 is not a prime factor. 2, because it can be divided by these two. And 2 is a prime factor. And yeah. And 6 is not a prime factor, so it can go. So you have to keep going. And see how I kept going when something is not a prime factor? Because all of the numbers have to be a prime factors, or this thing won't work. So now what do? When all of the prime factors of all of your numbers are underlined, you now look at the prime numbers that appear on all of your numbers. So let's see. 5 and 5 appear. Yep, so 5. 3 and 3 appear. Nice. 3 and 2. Yeah, that's it. So now what do? Then you multiply the numbers together, and that's your greatest common multiple. You multiply. Don't add, because when you add, it's going to get you 8. But when you multiply it, you're going to get 15, which is the right answer, because 15 can go in 45. Yep. 15 can go in 60. Yep. Check. So now let's move on to the next step. Prime and composite numbers. So you basically have to know what prime and composite numbers are when you do factor trees. Prime and composite prime numbers are numbers that are special. They only have two factors, one in itself. For example, it's like the only prime factors you really have to know in factor trees is the most common ones: 3, 5, 7, 9, and maybe 11. Composite numbers are the opposite. They are numbers that aren't special and have more than two factors. So basically like 4, 6, 8, 10, 12. You see how all the prime numbers are odd numbers, but all the composite numbers are even numbers? Yeah, that's what I'm going to tell you later. The easiest way to find out if a number is composite or prime is if it can be divided by 2. Because every even number can be divided by 2. Yeah, that's the easiest way. Every even number is divided by 2, so you can chop it in half. And yeah, so it's a composite number. But here's the thing though. Not all odd numbers are prime numbers. Because is 39 a prime number? No, it's not. Because it can be divided by 3. And you can always just check the divisibility rules if you don't know a certain number can be divided by another number. The divisibility rules are right here. You can pause the video and look at them if you need to. Next, let's move on. Word problem. Sack. Mr. Doherty is arranging tables for middle school. There are 25 students in grade 5, 30 students in grade 6, 45 students in grade 7, and 75 students in grade 8. He wants to have the same amount of people in each table. What is the greatest number of students he can have at each table? I'm just going to change my pen. So what you want to do always first is make a list. So MAL. That's really important. And maybe you can highlight your information. Let's highlight our information first. So Mr. Doherty is arranging. So he's arranging. There are 25 students in grade 5. 25 students in grade 5. Here, just write grade 5. 30 students in grade 6. Grade 6. 30 students? Yep, 30 students. 45 students in grade 7. 45 students in grade 7. Grade 7. 45 students. And in grade 8, there's 75 students. Pretty cool, huh? So 75 students in grade 8. Grade 8, there's 75 students. And this is also really important, he wants to have the same amount of people in each table. So it's the greatest common, because so it's common, so all the grades have the same amount of people in each table. Same amount of people at each table. And also the question, basically, what is the greatest? Yeah. What is the greatest number? So now we've made our list, we can do the real question. So let's do the factor trees method. Let's branch off some factors for 5. Well, okay. These are all prime numbers, so underline them. Now do 30. I'm going to do 3 and 10. 3 is a prime number. This is not a prime number, so I can keep going. 5 and 2. Wait. Get on my pen. 5 and 2. These two are both prime numbers. Now let's do the grade 7, 45 students. Branch off. I'm gonna do 15 and 3 now. 3 is a prime number. 15 is not. 5 and 3. Yup. And 75 in grade 8. 75. So we can do branch off some factors. Let's do branch off. 75 can go into 15 and 5. 5 is a prime factor. 15 is not. 5 and 3. Yeah. Now let's see what are the factors that are in here. So this has 1, 5. 5. These two match. There's a 5 in here, and there's a 5 in here. So there's 1 5 in all of the numbers. So mark that down. Is there another 5 in all of the numbers? No, there's not. There's not 2 5s in all of the numbers. Yeah, I think that's it. There was only one set of prime numbers. So it's just 5. Wait, actually, is there another one? No, there's no other one. It's just 5. So the answer would be, you would also write a statement. You would also write a statement that the most students he could have, change that to pen, most students he could have at each table is 5. It's 5. So that is our answer. Now let's move on. Worksheet. These are some questions that you can do by yourself. There's short answers you can see. There's solve the greatest common factor for the following numbers. There's word problems, true or false. There's multiple choice, word problem, true and false. Yeah. You can pause the video if you want to do these questions. Okay. Now this is a math game. So this is a math game you can do. So this is a math game. I'll show you how to do the math game right now. So see, you get onto the math game, and this is what the math game. So look, you can see, type what is the greatest common factor for 9 and 10. Do you guys know? Well, I think it's 1, because that's the only common factor out of these two. Yep, see, I'll show that I'm right. And okay, let's go back to math games. Let's move on, and thank you for watching. Bye. Peace out.